Hey everyone, welcome to Conceptual Geometry, Lesson 2.8, the Triangle Inequality Theorem. Let's consider the three scenarios. I'm going to give you three straws, all different lengths. Can you make a triangle from all three cases? Well, if we take a look at the first one here, I know it's kind of hard, it's just a two-dimensional representation, but if you can envision this side pivoting at that vertex and swinging down. Then we'll do the same thing with the other side. I think it's pretty obvious to see that you would not be able to make a triangle here because these two sides wouldn't touch. They would just fall right down. They wouldn't be able to be propped up. Okay, well, let's try the next scenario. Now we're going to increase this side to 3 and the other side to 4. Well, same thing. That would pivot down. This would pivot down. And here they would touch, but they wouldn't touch until they collapsed right on top of this base, which is length 7. Well, in the third scenario, I'll increase the sides to 5 and 4. I think you could see that that side would pivot and this side would pivot, and they'd end up hitting or being propped up like so. So that would make a triangle. This would be the triangle formed right here. All right, so which ones would make a triangle? It would be the scenario that had lengths 4, 5, and 7. And that basically is our triangle inequality theorem. The sum of the lengths of two sides of a triangle must be greater than the third side. And notice I use that word greater. Equal does not work because here they were equal. 3 plus 4 equals 7, but you see what happens? They would fall down, they would touch, but it wouldn't make a triangle. They would lie right on top of one another. And what I would like you to actually remember, and this is how we're going to test it, is that the smallest side plus the second smallest side must be greater than the largest side. That way we only have to do one test because sometimes you'll be able to add two sides up and it'll be greater than the other. But if you take the two smallest sides, and that's what we did up above, we took the two smallest sides. 2 and 3 were both smaller than 7. 3 and 4, both smaller than 7. 5 and 4, both smaller than 7. This is how we're going to test it right here. All right, so all we're going to be doing today is arithmetic and comparing. So in our first example here, it says, tell whether the given lengths may be the measures of the sides of a triangle. Make sure you pick the two smallest sides, so 4 and 6. And you're going to ask yourself, 4 plus 6, is it greater than 10? Question mark. I don't know if it is or not. Then what we do is we actually do the arithmetic, which again, it's going to be very simple, but we have to go through this process. It's almost like a proof. 10 is greater than 10. Question mark? No, it's not. It's equal. Equal does not work. So this would not make a triangle. How about the next one? 4 plus 6, is it greater than 8? Then you add up 4 plus 6, that's 10. Is 10 greater than 8? Yes. So in that scenario, it works. Those sides would make a triangle. The next one, here's where it gets tricky, because if you just get used to doing it left to right in order, you can't determine it, because notice 4 plus 12 is greater than 6, but we're not picking the two smallest sides. You always add the two smallest sides. So here I would do 4 plus 6, is it greater than 12? 4 plus 6 is 10. Is 10 greater than 12? No. Do not make a triangle. And then this one, 7, 8, 9. It's my favorite joke. Why is 6 afraid of 7? Because 7, 8, 9. Get it? Anyway, 7 plus 8, is it greater than 9? 7 plus 8 is 15. 15 is greater than 9, so yes. It's a pretty simple concept as long as you remember to take the two smallest sides. The two smallest sides must add up to be more than the third. Well, here's where we'll get a little bit more challenging. If I give you two lengths, I said the length of the third side may be. Well, here's one strategy. One thing you could do is you could take this choice here and mix it in with these two sides and write them out. So here we go. It would be 3, 3, 6. You put these three sides in order, 3, 3, and 6. And then you just do what we did up above. Is 3 plus 3 greater than 6? Is 6 greater than 6? No. So that doesn't work. Because it says here, maybe. You want the one that will work. And that's probably the best bet to start. So now let's, I'll use different colors here. Let's take choice 2. If I mix in a 9 with a 3 and a 6, I have to put those in order. 3, 6, 9. Okay, so that would be 3 plus 6. Is it greater than 9? Is 9 greater than 9? No. So that one doesn't work. Well, let's try this one, choice 3. 6. Well, again, you have to put them in order. 3, 6, 6 would be the correct order. Is 3 plus 6 greater than 6? Is 9 greater than 6? Yes. So it would be choice 3. And I'm just going to go through, that's what I do. I'm a math teacher. Let's just test this one to make sure it doesn't work. 3, 6, 12. You have to put them in that order. So is 3 plus 6 greater than 12? Is 9 greater than 12? No. So we picked the right one, choice 3. Now, just vocab here can get a little bit different. This one says, which of the following sets of numbers could not be? All right, so you've got to read carefully. We want the one that does not work. So very quickly, put them in order. It's 2 plus 3 greater than 4. 5 is greater than 4. So this is a yes or a true, but we want the one that is not. So that does work. Reject it. The next one, 3, 1, 1. Remember to put them in order. Is 1 plus 1 greater than 3? Is 2 greater than 3? No. So choice 2. And again, for the sake of notes, I'm going to go on and test the other ones. Is 3 plus 4 greater than 5? Is 7 greater than 5? That's a yes. But remember, we want the one that's false, basically. So I reject that. And then my last one here, 3, 4, 4. Is 3 plus 4 greater than 4? 7 greater than 4? That's also a yes. So I reject that. One of the reasons why I want you to do this is because sometimes if you don't see that word not and you think, oh, which ones will? And you get to choice 1, you're like, oh, yes, that one does. I'll pick that one. And you don't even test the rest of them. But what will happen on multiple choice is that one of them will be different. 3 of them will be the same. So that's part of a test-taking strategy that you want to go through and test all the choices. Time is not going to be an issue. Don't be lazy. Just test them all. So this example is similar, except it gives us the two sides and a possible third side. So it says here, if the lengths of two sides of a triangle are 4 and 8, the length of the third side may not be. So again, there's that important word, not. You want the one that's going to be false. We're given 4 and 8, so we mix in another 8. Put them in order. Is 4 plus 8 greater than 8? Is 12 greater than 8? Yes. This is a true. We want the false. Now we do a 5. Put the 5 in order with the 4 and the 8, so it goes in the middle. 4, 5, 8. So this would be, is 4 plus 5 greater than 8? Is 9 greater than 8? Again, check question marks. Again, yes, it is. Don't want that one. 7. 7 would also go in the middle. 4 plus 7 greater than 8. Yeah, 11 is greater than 8. So another yes. By process of elimination, I know it's got to be choice 4, but let's just verify it. It's a 12. So 12 would go on the end. Is 4 plus 8 greater than 12? Is 12 greater than 12? No, it's not. That is the one that is false. All right, our last example here. It says, which of the following triangles is impossible? basically does not exist. You might look at them and say, well, hey, you drew them for every one, so they're all possible. But not really. I look at the lengths of the sides. One of these is impossible. So let's test the first one. You pick the two smallest sides, and sometimes, the middle side might be the same as the largest side, or the small side might be the same as the middle side. But you just put those in order and try the inequality. Is 2 plus 4 greater than 4? Is 6 greater than 4? Yes. So that is possible, which means I don't want that as my answer. Next, we have 3, 9, and 11. Is 3 plus 9 greater than 11? Is 12 greater than 11? Again, yes, it is. That one is possible. Reject it. 5, 5, and 10. Is 5 plus 5 greater than 10? Is 10 greater than 10? No. This one's impossible. We'll just check the last one. Is 8 plus 9 greater than 10? Is 17 greater than 10? Yes. So this one is possible. Reject it. Obviously, choice 3 is our only answer. So that wraps up day 8 notes. Again, it's a pretty straightforward concept as long as you remember to take the two smaller sides. And it has to be greater than the third. The sum has to be greater than the third. Okay, guys, as usual, if you have any questions, don't hesitate to reach out. Thanks for watching, and we'll see you in class soon.